Oh, we were talking about geometric progression. Um, Geometric progression is very, very simple. It's only technical in some way. What is geometric progression in the first place? When a sequence has a common ratio between successive terms, it is called a geometric progression. For instance, let's look at this. This is arithmetic progression and geometric progression. What's the difference between them? In arithmetic progression, it's either we add or we subtract. For instance, we have 5 plus 2 gave us 7, 7 plus 2 gave us 9, 9 plus 2 gave us 11, and so on. But for geometric progression, you somehow multiply. For instance, let's look at this. 8 times 3 will give us 24. 24 times 3 will give us 72. 72 times 3 will give us 216. Or you say 216 divided by 3 gave us 7. 72. 72 divided by 3 gave us 24. And 24 divided by 3 gave us 8. Can you see the difference? Let's say the first term there we are having is what? A, and which is 8. A times R, the common ratio which is R is what? Is 3. It is normally symbolized or abbreviated as GP. The constant is called the common ratio. This topic is very, very interesting. It's something that you love to solve. For now, I'll be showing you an example that you have to make use of so as not to make mistakes when solving. This is one of the tough questions you can meet in WAEC or in other exams. So I'll be giving you a foundation that you can use to solve your own question. For now, we are looking for the 16th term of the GP for the progression or the successive terms of, let's have 1, 2, 3, 4, 5, 8, and so on. So we have 1, 2, 3, 4, and 8. Okay. So the formula for the GP is ARN raised to power n minus 1. It's very, very simple, something you will love to solve. So let's look at it. A there is the first term. Arg there, I can hear you say common ratio, and n is our nth term. For instance, let's say find the 16th term. So our nth term there is 16. You get that? Okay, just like what I just put there. The common ratio is 2, and 16 minus 1 give us 15. So 2 raised to power 15. So 2 raised to power 15, what will it give to us? You can punch that your calculator now. Or you can inbox me your answer anyway to show you are following us right now. Okay. So this we're going to calculate now 2 raised to power 15. So you can punch your calculator there. I'm showing you a live view of my own calculator here. We have 2 raised to power 14 here. Okay. 2 raised to power 14. 2 raised to power 15 rather. 2 raised to power 15. So it's giving us 32,768. 32,768. So the 16th term of the GP for 1, 2, 3, 4, 8 is 32,768. Okay. Now we want to solve a technical question now, because you guys normally say your teacher will solve something very simple and will give you something hard. So now just solve a very technical question which is quite tough. Yeah, so as not to confuse you guys with some tougher questions you can meet later. So we'll solve a tough question now. Now this question is very simple, but one more time, very technical. The question goes like this: the third and sixth terms of a geometric progression are 48 and 14 respectively. Write down the first four terms of the GP. What did they mean by here? What did they expect us to solve? How did they want us to solve this question? I think that is what should be dangling in your head right now. So the third term, that is going to be what? AR raised to power n minus 1, that is going to be 3 minus 1, that is 2, is that not? Which is equals to 48. Because the word respectively means the first will go for the first one and the second one will go for the second term. You get that? Just like 48 will go for third, 14 will go for sixth. You get what I'm saying? Okay, now they said the third and the sixth terms of a geometric progression are 48 and 14 respectively. Now we should write down the first four terms of the GP. What do they want us to find here? Most especially, they want us to find the first term and the common ratio. Having the first term and the common ratio, we can get the first term to the first four terms. Do you get what I'm saying? Okay, this is a live example right now. I'm just solving this. This for the first one, for the third term to be equals to 48. Now this is for the sixth term equals to 14. Now AR, the same thing, 6 minus 1. And that will give us AR raised to power 5 equals to 14. Equation 2. Okay, do you have any question here? Let me know in the inbox below if you have any question, but it's quite explanatory. Okay, now we're going to make use of this equation 1 and equation 2 together now. Now we're going to solve them using substitution method. What do I mean by substitution method? For instance, now we have AR raised to power 5 equals to 14. So now I can make A the subject of the formula there. Okay, let's make use of AR raised to power 2 equals to 48. Now for the equation 1, I can divide both sides by R raised to power 2. You get it? And I'll be left with A, making A the subject of the formula. For now, I want to put down the equation 2. I will have here AR is power 2. AR raised to power 5 equals to 14. Equation 2. Okay. Now, if you have solved questions similar to substitution method, where you just input one equation to the other equation to find one unknown or the second unknown, you get that? This will be more simpler for you. And for those who have not solved something like that, I will show you a live example right now. Okay, for now I want to make A the subject of the formula. I can either choose equation 1 or equation 2, any of it. I can make any of them the subject of the formula, A subject of the formula at that point. And what I'm going to do is that I'm going to impute it to the other equation so as to find my answer. Okay, so I'm going to make A the subject of the formula in equation. Guess which of the equation should I go for? I say okay, equation 2. Okay, now AR raised to power 5 equals to 14. I have to divide both sides by what? You say okay, R raised to power 5. Now when I divide both sides by R raised to power 5, you will notice that R raised to power 5 will cancel each other, and I'll be left with A equals to 14 over R raised to power 5. Okay, so A is equals to 14 all over R raised to power 5. It's quite simple, is that not? Okay, or you can call it 14 into bracket R raised to power 5, close the bracket, raised to power minus 1. It's still the same thing as divided by R raised to power 5. Because of that, raised to power minus 1. Okay, we are going further now. Now this answer I got for A here, remember we make use of what? Equation 2. I'm going to now use this 14 divided by r raised to the power 5. I'm going to substitute that A into equation 1, not into equation 2 again. No. We're into equation 1 because I use A as the formula for equation 1. So that A I'm going to use for equation. I use A for solve the formula in equation 2. So I'm going to substitute that A into equation 1 so as to find my R. You get that? So I'm going to use that to look for my R, which is my common ratio. I'm going to find my common ratio now. So now I'm going to be having A into bracket 14. Okay. Let me show you what I mean here. Okay, are you ready? So A r raised to the power 2 equals to 48, which is equation 1. We're going to make use of equation 1, like I said. Now in this equation 1, I want something for you to understand something. I will bracket this A now. Remember that the A now is now equals to what? 14 all over r raised to the power 5. Okay, times r squared equals to 48. Remember we have r raised to the power 5 and we have times r raised to the power 2. 14 times r raised to the power 2 over r raised to the power 5. So can they cancel out? Yes. How? How will they cancel out? Remember r raised to the power 2 is like saying r times r. R raised to the power 5 is r into 5 places. That is r times r times r times r times r. So what will be left? To be left with r raised to the power 3. Do you get what I just did now? So 14 divided by r raised to the power 3. Let me show you again. I love to show live examples so that you can get what I'm trying to say. Okay, divided by r times r, which is r squared. So let's cancel out. R will cancel r. R here will cancel the r here. So we are left with 3r, which is r times r times r. That is r cubed. So here we're going to cross multiply. Cross multiply in terms that r raised to the power 3 with times 48. You get that? And 14 with times 1. Okay, so we're going to be left with 48 r raised to the power 3 is equals to 14. 14 is equals to 48 r raised to the power 3. What you can do is divide both sides by 48 so as to be left with r raised to the power 3. So divide both sides by 48. 48 to cancel out in the left hand side, or in the right hand side rather. Or by in the left hand side, we'll divide it using our calculator or so. And r raised to the power 3, when the raised to the power 3 is cancelling out, it's going to the other side, it will become the cube root of that, just like 3 root 7 all over 24, like we have there. And this 3 roots is different from the normal solving you are used to. So this is having 7 divided by 24. So we have 0.291. Now I told you that the 3 roots there is different. It's just like me saying 3 roots 27. 3 roots 27. I simply means 3 numbers that when I multiply them together, they will give me 27, and that is 3 times 3 times 3. 3 the same number, 3 the same number. Then when I multiply them together, they will give me what? 27. If I say 3 root 81, I mean 3 the same number that when I multiply them together, they will give me 81. And what is that number? And also, or if I say 3 root 125, I simply means 3 numbers that are the same, that when I multiply them, it will give me 125. For instance, 5 times 5 times 5 will give me 125. So my 3 root 125 is equals to 5. Do you get that? So here now we're looking for the 3 root of 0.2 9 or 2 something. Let's check it again. So when you find the 3 roots, you have to make sure that your calculator can solve this thing very well. Before you use your calculator, make sure you test it. You test run it on any device. Check it under your calculator. Try to do 3 roots 1 to 5. If it should give you 5, that means it's giving you the right answer. But if it's not giving you that, you are doing the wrong thing. Okay, so 3 roots of 0.2. 0.299, are we 292? Okay, 292. 3 roots 0.292. I'll be showing you a live view of my own calculator. Can you see the way my own 3 roots look like? It's not the usual 3 roots. Okay, 3 root 292. So 0.663 is the answer. If you multiply this 0.663 times 3, like 0.663 times 0.663 times 0.663, it will give us the 0.292. If you multiply it 3 times, you get that. So that means 0.6663 is our 3 root of 0.292. I hope you understand what I just did now. Or I just said now. Okay, please don't make mistake. Okay, so our common ratio is equals to 0.663. Okay, cheers to Blessing. She did her birthday. She was the one that sent this question. So I want to just say happy birthday to her. So let me proceed. Okay. Let's now substitute this R into any of the equation. If we substitute to the first equation, we'll get the same answer. If we substitute into the second equation, we'll still get the same answer. So any of the equation, you can make use of it. Maybe equation 1 or equation 2. Any of it, you still resolve in the same answer. Okay, substitute into equation, or what equation do you want us to substitute into? Yep, you said. Okay, let's choose equation 1 or equation 2. Which of the equation? Now, remember our equation 1 and equation 2. We said a r raised power 2 is equals to 48, and a r raised power 5 is equals to 14. So equation 1 there and equation 2 here. Is it not very, very simple? Okay. Okay. So now, which of the equations should we make use of? 0.663. Which of the equation are they making use of now? Okay, equation 2. Okay. So what is 0.663 square? What will it give us? You can also test it using equation 2. So if your A is not giving you the same answer as mine, that means you are either wrong or you did not solve it very well. So you should check it very well. So equals to 48. So divide both sides by 0.44. Okay, so A will give us 101.1. Okay, let's try it in equation 2 and see if you're going to have the same answer. What did you have for equation 2? Did you also arrive at the same answer? Check, verify. If you have the same answer with mine, please comment on the checkbox there below. Okay. Want to still test it for equation 2 now. Okay, raised to power 5 is equals to 14. I just want to check again. There's no need for you to solve this. If you just want to verify if your answer is correct, I told you can put it in any of the equation and to give you the same answer. Okay, So okay, that one is A equals to 109.1, not 101.1. It's a mistake. 109.1. Okay. So we want to try test it again. We want to use 0.663 times 0.663 till 5 times of it. Okay. So what will they give us? 0.128. Okay, increase equals to 14. So if you multiply 0.635 times, it will give us 0.128. A equals to 14. So we're going to divide both sides by 0.128. Okay. Want to check the answers if they are correlating, they are the same. Okay, so A is equals to 14 divided by 0.128. So can you see that they are both the same, they are both correct? We are having 109 points. So they are both correct. Okay. So now we want to proceed into finding the first term, the second term, third to the fourth term. Because the question says find the first 4 terms of the GP. So remember, the first term will be what? So the first 4 term, for the first term now, I'll be having A raised to power R raised to power n minus 1. For the first term, that is 1 minus 1, and that is 0. So R raised to power 0 is what? Is 1. So A is what? A is 109.34. So my final answer for the first term will be 109.34. Okay, let me show you what I mean by that. For first 4 terms, for the first 4 terms, so like I was saying, for the first 4 terms, A R raised to power n minus 1. The first term now, we now know the first term to be 109.34, and the common ratio to be 0.663. But meanwhile, at this point, our first term is what? 1. And that is n. Our n there is 1. And 1 minus 1 is what? Is 0. So A is 109.34. Okay. It's like a 0.663. Raised to power what? 1 minus 1, which is 0. So 0.663 raised to power 0 will give us what? 1. And 1 times 109.34 will still give us 109.34. Because 1 multiplied by any number will still give us that same number. I hope you understand what I'm saying. So the answer is 109.34 for the first term. How about for the second term? Now for the second term, we have 109.34 times our common ratio, which is 0.663, raised to power n minus 1. The n there is what? Is 2 now for the second time. So 2 minus 1, and which is 1. So now n raised to power 1 will still give us that same number. So we have 0.663 raised to power 1 times 109.34. So using my calculator now, 109.34 times 0.663, what will they give us? What will our answer resolve to? So I cycled the final answer for A, which is the first term, and half, which is our common ratio. So we're going straight to what we have when multiplying. I'll be showing you a live view of my calculator now. We have 109.375 times 0.663. Okay, so we have 72.51. So second term final answer is equals to 72, not 17, 72.51. Okay, 0.52 due to approximation. Okay, now we are to look for the third term. By now you should be able to solve the third term by yourself. Should be nothing hard for you anymore to solve. It's very simple now. So what you just do is the first term, which is 109.34, times the common ratio, which is 0.663, raised to power n. N now will be 3 minus 1, and which is 2. Okay, so 0.663 raised to power 2, just like saying 0.663 times 0.663. Any answer you resolve to, you multiply it by 109.34. So what we have now? Okay, you have few minutes to solve that. The reason I'm giving you this is that when you solve it, it will be more engaging. You too, you practice it, and possibly if you make mistake, you can be able to correct yourself. At least you are far more better than 90 or 100 more people that have not even started solving this at all. So in the exam, you will not be new to it. You have understand one or two topics. Okay, this is not just a tutorial just like that, just to boost your memory alone, but to help you to practice it so that you too can learn. So this is 0.663 times 0.663 times 109.345 or 353,345. So final answer is 48.06. So we have 48.06. Check it again. 48.06 to be our answer. Okay, 48.24. If you have 48.24 or 48.06 or 48 point anything, at least you are close. Yeah. Okay. So from here, we can now resolve to finding our fourth term, which is still the same process. Only the difference there is now be 4 minus 1. And 4 minus 1 is 3. So 0.663 raised to power 3. So what do you have as your final answer there? Zero 0.663 raised to power 3. Make sure you get it, you understand it, you can solve it. Okay, I will show you a live view of my calculator again. 0.663 times 0.663 times 0.663, 3 times. Now anything you have, you multiply it again by 109.345 or 375. Okay, 109.75. Now we're having 31.98. At least you have gotten the way to solve this. So you should also endeavor to solve it right. You're no more new to this anymore. Okay. So final answer is 31.985 for that. Please solve it and tell me what you also got. What was your answer? Okay. Are you there? Oh, please like and share this video. Share to your peers. Share to those who will love to have this with them, which will help them to boost their knowledge one way or the other, to help them to increase their understanding on geometric progression. What we do here is we solve past question, we solve maths, circuit theorem, anything engineering, we solve them, at least for the basic knowledge, basic foundations. We help to build brand students and young learners. So for the viewers, live students, we would like to have one or two comments from those people that have also written this geometric progression before. What was their experience? How can they help you with their experience? What can you learn from it? One or two things. Okay. Yeah. Mr. Sam.
Good evening, good afternoon.
Yeah.
Good evening, my people, my fellow students.
Okay.
My name is Samuel. I want to make comments on my experience about this AP and GP, which means arithmetic progression and geometric progression. When I'm in secondary school, then in 2017, I did this course, this topic rather, AP and GP. Though they first taught us AP, which means arithmetic progression. That AP, I love the course. I love that AP because it's very simple. When you move to GP, that GP is somehow hard.
You mean the geometric progression?
Yes, it's somehow hard because it's so technical. Like you just need to think. But though after we read, we go to some lesson, and we met our seniors. They taught us, and though we thank God, sha.
You guys did well. So how do you think this live tutorial will be beneficial to the viewers?
This tutorial will help you people, especially you people that are in secondary school.
Okay.
This thing will help you. Just stay focused on it because you will still need this when you go to an institution for sure.
Yeah.
You still need it. But try to concentrate on it, study it very well. And I know that this thing will help you in future. Trust me.
Okay. Just like for those people that are just starting this geometric progression, some of them have come back from school. They might be very tired. You understand?
Okay.
So this thing they can just open their tab or open their phone, anything, and try to watch it at their own convenience time.
Yes.
You know now, at any time.
Yes.
Even the night, anything.
Yes.
It's different from just say your uncle or your teacher. You wake your teacher in the night, come and teach you
again. If you watch this video, I know everything that you don't understand in school.
And they're also free to do what? To drop comments.
Okay.
On any questions that they don't understand or anything that is not still explanatory to them. They can also drop it in the comment box below. Thank you, Mr. Sam. God bless you.
You're welcome, my brother. We did
See you later.